Next problem. Tangents to the hyperbola x square by a square minus y square by b square is equals to 1. Make angles θ1 θ2 with the transverse axis of the hyperbola. Show that the point of intersection of these tangents lies on the curve 2xy is equal to k into x square minus a square when tan θ1 plus tan θ2 is equals to k. So given the tangents to the hyperbola, makes angles θ1 θ2 with the transverse axis of the hyperbola. So here the transverse axis is nothing but the x-axis, since it's a standard form of the hyperbola. Transverse axis means we take the x-axis. So θ1 θ2 are the angles. Now show that the point of intersection of these tangents lies on this curve. So given conditions, tan θ1 plus tan θ2 is equals to k. So first we write the given hyperbola equation. Given hyperbola is x square by a square minus y square by b square equals to 1. Next we take the point of intersection of the tangents. Let P is equals to x1 y1 be the point of intersection of the tangents. Now we want to show that this point lies on the curve 2xy is equals to k into x square minus a square. So this is the point of intersection. And what is the equation of tangent? Already we know that the equation of tangent with slope m is y is equals to mx plus or minus square root of a square m square minus b square. Now the point x1 y1 is a point of intersection of the tangents, means the point of intersection lies on this line. So we are substituting that point in this equation, which implies y1 is equals to mx1 plus or minus square root of a square m square minus b square, since the point of intersection lies on the tangent. That implies y1 minus mx1 is equals to plus or minus square root of a square m square minus b square. Now squaring on both sides. Then y1 minus mx1 whole square is equals to a square m square minus b square. Here square and square root gets cancelled. Now taking the expansion here, y1 square plus m square x1 square minus 2m x1 y1 is equals to a square m square minus b square, which implies y1 square plus m square x1 square minus 2m x1 y1 minus a square m square plus b square equals to 0. That implies, now taking m square common from the second and fifth terms, m square into x1 square minus a square. Next writing the m term, that is minus 2m x1 y1. Next writing the remaining terms, which are y1 square minus b square equals to 0. Now clearly this is the quadratic equation in terms of m. So we take that let m1 comma m2 be the roots of this equation. Now what is the sum of the roots m1 plus m2? The formula is minus x quotient by x square quotient, that is minus m quotient by m square quotient. Minus of minus 2x1 y1 by m square quotient, x1 square minus a square. What are m1 m2? m1 m2 means slopes of the tangents. Already we know that the tangents makes angles θ1 θ2 with the x-axis. That is, we take the formulas as m1 is equals to tan θ1 and m2 is equals to tan θ2. Replacing those values here, m1 means tan θ1 plus m2 tan θ2 is equals to minus of minus plus 2x1 y1 by x1 square minus a square. But already given that the value of tan θ1 plus tan θ2 is equals to k. This is the given condition in the problem. So we are replacing this value at this place. That is k is equals to 2x1 y1 by x1 square minus a square. Now taking the cross product, we get 2x1 y1 is equals to k into x1 square minus a square. So clearly from this equation we can say that the point x1 y1 lies on this curve. Therefore the point px1 y1 lies on 2xy is equals to k into x square minus a square. That's all. That's the answer.